Here's the solution to problem number 3 from section 8.4. This is using the divergence test, which is really just a matter of checking whether the terms that are being added together are even getting small. So in this problem, if I write out the first few terms, and this is not necessary to apply the divergence test, but I just want to see what we're looking at. So when k is 2, this term will be 2 over log 20. When k is 3, this will be 3 over log 30, then 4 over log 40, and so on. So those are the numbers being added. The divergence test says that if these individual terms are not headed towards 0, then their sum can't possibly be a finite number. And so the only thing we have to do with the divergence test is check the limit as k goes to infinity of k over natural log of 10k and find out what that is. If this is 0, then the divergence test is inconclusive. If this is anything but 0, then we know that the series diverges. This is a ratio of two of our elementary functions, and so it makes sense that we would apply L'Hopital's rule. Notice that the numerator is going to infinity and the denominator is going to infinity. So this is a question about the relative growth rates of the top and the bottom. If I want to apply L'Hopital's rule, I need to recast this problem in terms of the continuous variable x. Because remember, I can't really, if the k is representing whole numbers only, then technically I need to be in terms of the continuous variable x in order to be able to take a derivative and apply L'Hopital's rule. So L'Hopital's rule says that the limit of this ratio is the same as the limit of the ratio of the derivatives. So the derivative of x is 1, and this is L'Hopital's rule that I'm using right here. The derivative of the denominator, the derivative of the log of something, is just 1 over that thing, and then I have to multiply by the derivative of that thing. And so if you resolve those fractions, I'll have the limit as x goes to infinity of 1 over, I have 1 over 10x times 10, so that's 1 over x, which is the limit as x goes to infinity of x. So the conclusion is that this ratio, k over log of 10k, is heading to infinity. So these individual terms, this is one of the worst cases we could have, these individual terms are actually getting bigger without bound. And so if I add together numbers that are getting bigger and bigger and bigger, so the numbers themselves are getting close to infinity, so certainly adding them together has no chance to converge to a finite number. So this series diverges because the terms do not go to 0. Again, if the terms did go to 0, all we could say is that the divergence test is inconclusive. Just because all the terms are going to 0 does not mean that their sum is going to be a finite number. But it's definitely true that if the terms do not go to 0, then there's no way that the sum can be a finite number.